Good morning to everyone. Today our class is on parallelogram law. Which we are having in engineering mechanics. For this we have to take two forces. If two forces acting at a point that means if I take two forces like this, force A, force P and force Q. If you see here, I am taking these two forces at a point, force P and force Q. If two forces are acting at a point represented in magnitude and direction by the adjacent sides of a parallelogram, sides of a parallelogram. See, I have taken these two forces, one is P and one is Q, and if we take a parallelogram where we can see that in the shape like this, and I am taking this as Q and P and this as Q, P and Q. These are the two adjacent sides of the parallelogram. I have indicated them. P and Q started at a point both in magnitude and direction, which arrow marks indicates the direction and P indicates the magnitude for force P and Q indicates the magnitude for force Q. Now their resultant is represented both in magnitude and direction by the diagonal of the parallelogram, which we can see like this. This is the diagonal which is represented as the resultant. This is represented by with the arrow and it represented by the letter R, resultant. Now we have to find out the value of R. What is the resultant? That we have to assume a parallelogram like this, and if we extend this P, taking O as center, OA as P, OB as Q, and OC as R, and OT. Now if I take angle between the two forces as alpha and angle between the resultant and one of the force P as theta. Now if you see here, OA is P and OA is a horizontal line, and if we See, OA is P and the side BC also represents the force P. Same as OB is Q and the side AC also represents Q. And the angle between Q and the horizontal line is alpha. So the angle between the Q and here horizontal line is also alpha. I hope that you are understanding this. Now, to bring out the value for the resultant, I am using the triangle ACD, which is small triangle. Which is a small triangle. Okay, now if we take sine alpha is equal to, sine means opposite by hypotenuse, is equal to opposite side is CD and hypotenuse is AC. Now we are having AC is equal to Q and we have to find CD. Now sin alpha is equal to CD by Q. That implies CD is equal to Q sin alpha. Next, now we have to take cos alpha. Cos is equal to adjacent side by hypotenuse, where adjacent side is equal to, we are having AD as adjacent side, AD by hypotenuse is equal to AC. AD by AC, where AC is equal to Q. Cos alpha is equal to AD by Q. That implies AD is equal to Q cos alpha. Now we are having two values here. CD is equal to Q sin alpha and AD is equal to Q cos alpha. This we brought from the small triangle which is A, C and D. Here we are having AD value and here we are having CD value. Now if we take the large triangle, that is OCD, from Pythagoras theorem, hypotenuse square is equal to side square plus side square, where hypotenuse is OC square is equal to one of the side OD square plus CD square. Now if you see here, OD is equal to OA plus AD. OD is equal to OA plus AD is equal to OA plus AD whole square plus CD whole square. This If we think OA as 5 meters, OD as 5 meters, OA 3 is 2. That means 3 plus 2 is equal to 5. Directly if we take OD is equal to 5 meters, that 5 meters is equal to OA 3 meters plus AD 2 meters. 3 plus 2 5 meters. So I am taking that OD is equal to OA plus AD. Now if you see here, A plus B whole square formula, A square plus B square plus 2A into B plus CD square remaining term. Now if you see, OA means P square plus we got the value for AD. AD is equal to Q cos alpha. Q cos alpha whole square plus 2 into OA means P. Next AD means Q cos alpha plus remaining term CD. CD means we are having the value CD is equal to Q sin alpha. Q sin alpha whole square. Now squaring. P square plus Q square cos square alpha. If we divide this square root to everyone, we get Q square cos square alpha plus 2PQ cos alpha plus here also Q square sin square alpha. Now P square plus, if I take Q square as common, we are here the term remaining is cos square alpha, and here the term remaining is sin square alpha plus remaining term 2PQ cos alpha. Now P square plus Q square into 1, where this relation is equal to 1 plus 2PQ cos alpha is equal to P square plus Q square plus 2PQ cos alpha. What is this is equal to OC square, where OC is equal to R square. So R square is equal to P square plus Q square plus 2PQ cos alpha, where R is equal to, if that square comes to this side, we will get root of P square plus Q square plus 2PQ cos alpha. This is the value for R, which is the resultant of the two forces. And for example, if we take these two forces, we can imagine that a catapult means a stone thrown from a catapult. It will move like that. And the wings of a bird. These are the two examples for this. And if we take these two forces, their resultant must be in the middle. That means the resultant is the effect of the two forces, the force P and the force Q, and R is the resultant of that two forces. So the value of that resultant is R is equal to root over P square plus Q square plus 2pq cos alpha. For this I had done first, I had taken a small triangle which is ACD, and from that I used sin alpha and cos alpha. And for the second time I have used the large triangle which is OCD, and from that I used Pythagoras theorem, which is hypotenuse square is equal to side square plus side square. From that a plus b whole square, a square plus b square plus 2ab, and oa as a, od as oa plus ad. From that calculating we get r is equal to root over p square plus q square plus 2pq cos alpha. And now if we want the direction of the resultant, direction of the resultant, direction of the resultant, here I am indicating direction of the resultant as theta. Why? Because if we see in the diagram, the resultant is shown by r, which is having some angle theta. That means if theta is equal to 30 degrees, we can say the direction of the resultant is with some angle theta which is 30 degrees. If that theta is 90 degrees, we can say that the direction is moving in the north side, is on the north side. And if it is having 45 degrees, theta is equal to the direction is in between northeast. So that is why theta is indicating the direction of the resultant. So for that I am taking tan theta. So for that I am taking tan theta, which is opposite by adjacent. This is opposite by adjacent. Here from the triangle OCD, where opposite side is equal to CD by OD, is equal to tan theta is equal to CD by OD, can be written as OA plus AD, where we are having CD is equal to Q sin alpha. So that is why CD, in the place of CD I am writing Q sin alpha by OAP plus AD means Q cos alpha. So tan theta is equal to Q sin alpha by P plus Q cos alpha. Therefore theta is equal to tan inverse Q sin alpha by P plus Q cos alpha. This is the formula for the direction of the resultant. This is the parallelogram law, which deals with the two forces that acting at a point. The statement itself indicates if two forces acting at a point be represented in magnitude and direction by the adjacent sides of a parallelogram. Here these two forces are the adjacent sides of a parallelogram and their resultant, and the effect of these two forces is indicated by the diagonal of the parallelogram. See that I have indicated the resultant is represented both in magnitude and direction by the diagonal of the parallelogram. Okay, na? Diagonal of the parallelogram, that is the statement for this parallelogram law, and this is the derivation, and this is very important in engineering mechanics. Thank you.